Hey, awesome kids. All right, so this recording, it's for 9-3, okay? We will start with example 2. In example 2, the directions is write each complex number in rectangular form. So in rectangular form, what we will do is then it's gonna be a lot easier than what you think. So first, we will write the 3 down because that's the radius. Cosine of 210. 210 is in quadrant number 3. So cosine in quad 3 is going to be negative radical 3 all over 2. And then we're going to drop down your I, okay? Sine of 210 in quad 3 is a negative 1 over 2. What do we do from here? Remember, rectangular form, okay? It's going to be x plus yi, okay? So from here, we can just distribute, and then that's it. So when we distribute the 3, it's negative 3 rad 3 all over 2. And I'm going to multiply the 3 to the negative 1/2. So this is going to be a negative 3 all over 2, and I'm going to put the I behind it. And this is the final answer. In complex form, I'm sorry, it's already in complex and in polar form. Now this is complex rectangular. So now one of the questions is like, hey, do you want me to put it all over that common denominator of 2? No, don't do that, because in complex form, we always write it as y, x plus yi. Okay, so this is going to be your x right here, okay, and this is going to be your y. Okay, your y is negative 3 over 2, and your x is a negative 3 rad 3 all over 2. Okay, so don't put them over one common denominator. Next, we are going to try b. B, we are going to do the same thing. Okay, we're going to write 4 down. But I'm going to be stuck. I do not know what cosine of pi over 10 is. So I'm going to bust out my calculator. You know, hopefully you trust me. Pi over 10 looks like that's in radians. So I'm going to change my calculator, double check my calculator, make sure I'm in radians. Okay, so cosine of, and if you have a calculator ready, I would love it if you can double check my work. So cosine of pi divided by 10, my trusty calculator says, I have it at about 0.95, okay, or 951. It doesn't say how to round, so you can round it as far as you want. So plus I times sine of pi divided by 10 in radians, it's 0.309. Okay, so if I did that 3 decimal places, how about if I add another 1 on the cosine, just to keep it the same. So what we are going to do now is we are going to distribute your 4, okay? In rectangular complex form, the radius isn't factored out, so we have to multiply it back. So when I multiply it by 4, since I already have this out, I'm going to multiply this first, okay? So 1.2, how about 1 point, since I'm rounding to 3 decimal places, I'm going to keep it consistent, okay? 1.236i, so that's that first one. Then I'm going to multiply 4 to my cosine of pi divided by 10. So this is going to give me a 3.804. So that's your x plus yi, and that's the final answer. Okay. Next, example 3. Find, you're giving z and w. Okay, so find when z multiplied to w and when z is divisible by w. Leave your answers in polar form. So A, it's already in polar form, so I don't have to do anything special except that we will multiply first. So in multiplication, okay, let me remind you of what we do when we multiply. When we are multiplying, we multiply the radius and we add the angles. Okay. When we divide the radius and we subtract the angles. So keep that in mind when we're working these out. So multiply first. So that means I'm going to take my 2 radii. So 4 times 2. Okay. Then I'm going to add my angle. So cosine of 3 pi over 8 plus 9 pi over 16. So that's the 2 angles adding together. Plus I times sine of 3 pi over 8 plus 9 pi over 16. And from here, I would just sit here and simplify. So let's work it out. If they give you radians in the original problem, then keep it as radians in the original problem, okay? So common denominator tells me that this is a 16. So this would turn into 6 pi. So 16 and 6 pi. So my final answer when I multiply is 8, okay? Then cosine 6 pi plus 9 pi is now what? So is that 15 pi over 16 pi? Okay, very good. Then plus I times sine of the same exact angle. Okay, so that is what we do when we multiply. Okay, so the formula seemed, when we were reading the formula in class, it sounded really scary, but when you are really working it out, it isn't that scary. Now, what do I do when we divide? So just like a minute ago, we will take the two radii and we divide them, okay? And we are now going to attempt to subtract your angles. So take the first angle, subtract the second angle, okay? So same thing on this side. First angle, 3 pi over 8, subtract 9 pi over 16. Yes, I would now need to go and find common denominator. Since we did the multiplication above, this one should stay the same, right? We're still at 6 pi. So here we go. All right, so when we divide z over w, final answer is 2 in the front. So now your radius is 2. 6 minus 9 pi over 16 is now cosine of negative 3 pi over 16. We will talk about that in just a second. Plus I sine of what you get on the first angle, you're going to get on the second angle. Okay, so here's the negative angle. Now in your book, it really doesn't like negative angles because I believe when we define this, it says that theta, radius always has to be positive and theta always has to be from 0 to 2 pi or 0 to 360 depending on if you're in degrees or not. So what we need to do is convert negative 3 pi to 16 in positive angles, okay? So final answer is z divided by w equals 2 times cosine of. Now how do I convert negative 3 pi over 16 to positive angle? What would you do? Let me draw it out for you so you have an idea what negative 3 pi over 16 is, okay? So here's a negative pi over 2. In common denominator of 16, this is really negative 8 pi over 16. So negative 3 is just right there, that very small amount, okay? Oops. So here's negative 3 pi over 16. Because we define it as a positive angle, here's what we need, okay? So would you agree that I can take my negative angle and add a positive 2 pi, okay? Positive 2 pi then leaves me to believe, let me get a different color pen really quick, that I can make a common denominator of 16. So if that's 32, okay, 32 pi. So negative 3 pi plus 32 pi, now you are at a positive 29 pi over 16. Okay. And that's how you convert all of that to positive angle. So now, with positive angles and positive radius, okay, the division of z divided by w is 2 times cosine 29 pi over 16 plus I times 29 over 16. So that is for that one. Now, what if they give you a problem, but that's not in polar form? Then guess what? You have to do a little bit more work, okay? I first had to convert it in polar form. So to convert it in polar form, I would need to find r and theta, okay? So let's find r for z. So for z, r is square root of x squared plus y squared, okay? X squared is 1. 1 squared is 1. Y is negative 1, but negative 1 squared, it's also 1. So radius is 2 for z. I'm sorry, rad 2. Then I also need to find theta. So theta for z is tangent inverse of y divided by x. Let's sketch out where z is. Okay, so I want to make sure if I need to add up high or in degrees, 180 or not. X is positive, so I'm positive, and then Z is going to be, I'm sorry, Y is negative. So you're in quadrant 4, okay? So theta in quad 4, I can totally handle that, okay? Y is -1, X is 1, so this is a multiple of 45 degrees, okay? If you punch this in your calculator is going to give you a -45 degrees, but you can't have a -45 degrees because theta is restricted from 0 to 360. So I would now have to use 315 degrees, okay? So that's theta, and that is R. So now let's put it in polar form for Z. So Z is square root of 2, okay, times cosine of 315 degrees plus I times sine of 315 degrees. No, we have not done multiplication yet. We're just converting to polar. I will now try to graph out W to see what quadrant that is in. X is positive, Y is negative again. So again, I'm in quadrant number 4. The reason I do that is because I want to make sure if I need to add, when I'm looking, add 180 degrees or not when I'm looking for theta. So W equals, let's find radius, okay? So R equals square root of X squared plus Y squared. X is 1, so 1 squared is 1. Y is negative rad 3. Negative rad 3 squared is 3. So this is going to give me square root of 4. Square root of 4 is 2. So the radius for W is 2. I will now attempt to find theta. Okay, so theta is always tangent inverse of Y divided by X. So tangent inverse of Y is negative rad 3, X is 1. We're in quad number 4. This, if you put in your calculator, okay, let me give you, it would totally give you a negative answer. Yes, it will give you a -60. But we can't have a negative angle for theta. So we're going to go the other way around. Oops. -60 is equivalent to 300 degrees in the positive rotation. So W equals 2 cosine of 300 degrees plus I sine of 300 degrees. Okay, so that's just what Z and W converted to. So now I will attempt to find multiplication of Z times W. To do that, I will multiply the radii. Okay, the radius with radii is really the correct term. So rad 2 times 2 is 2 rad 2. In multiplication, I will add my angles. So cosine of 315 plus 300 and plus I sine, same thing, 315 plus 300. Now because this problem did not start out in radians, so most of the time when it doesn't start out in radians, you can just put it in degrees, okay? But if it starts out in radians, then you keep it as radians. So final answer, when I combine these, it's going to be 2 rad 2, okay, times cosine of, okay, well 315 plus 300 is now 615 degrees. And we are going to talk about, we can't keep that at 615. Sine of 615 over here as well. 615 is over a revolution, but theta, remember, theta was restricted to just the first revolution. So at 315, I can subtract it from a full revolution. Okay, so side work. 615 I meant, not 315. 615, okay, it's the angle we have. Take away a full revolution. So you should end up at 225? 255. Okay, there you go. So let me confirm really quickly. 615 minus 360. 225. Okay, so this is now at 255. I am sorry, 255. Okay, so 615. Okay, take away a revolution. It's the same location as 255 degrees. So that's what we would use instead of 615. And yes, you do have to bring it back to the first revolution. Okay. So 255 degrees here as well. So that is the answer if we were to multiply them. Okay. Now let's do division. Woohoo. Okay. So z divided by w equals, so z has a radius of radical 2. Okay. W has a radius of 2. I will now try to subtract the angles. So cosine of 315, take away 300 is now just cosine of 15 degrees. If you have cosine of 15 degrees there, you will also have cosine of 15 degrees here. And I am done with my division problem. Now, if this is going too fast, please do pause it, okay? Next, we are now going to work out problem or example number 4. And did I tell you that if this is too fast, please do ask or just pause it, okay? Example 4. Oh, my formatting. How frustrating is this? Okay. Write each expression in standard form of a plus bi. So, well, okay. I have some space between there, so I guess we'll start down here, okay? So a plus bi is the same as just x plus yi, okay? So don't be stressed out if you see different variables. So radical 3, as you can see, okay, I want to make sure. So radical 3 times cosine of 15 pi all divided by 18 plus I sine 15 pi all over 18. Okay, so what we are going to do is, before we start this, I'm going to have to go back and I want to make sure I'm going to give you the definition before I forget, okay, of De Moivre's theorem. We're going to use that soon. Okay, so here we go. Here's De Moivre's theorem. Okay. So De Moivre's theorem says that we know how to multiply the two polars, okay? We know how to divide the two polars. What if I don't want to multiply and what if I don't want to divide, okay? So is there another way that we can do this? Like power to the power, okay? So this is where it comes in. If z equals r, okay, times cosine of theta plus I times sine of theta. So this is just a complex in polar form. Is a complex number in polar form. Okay, so same formula that we have seen. Then we know how to divide, we know how to multiply. But what if I now want to raise it to a power? So z to the n equals r to the n, right? There's no surprising there because when you multiply radius. Then we have cosine. What do you do with power? Well, no surprising here either. You multiply n to the angle, okay? And that's it. So sine of n times theta here. Okay. Now, what is n? Okay, n is an exponent. So n, okay, where n, it must be an integer. What does that mean? Okay, that means is 1, 2, 3, 4, 5. Okay, and because to a power of 1, it's pretty boring. So let's make it an integer that's greater than 1. So like 2 and up. Okay. Then what if I want to find the complex root theorem? So complex root theorem, I'm gonna use different color pen. It says let. Okay, so instead of z, we're going to use w. The variables don't make any difference. Let w be some radius times cosine subscript, so cosine of theta subscript 0. That just means angle, the first angle, no big deal, okay? Plus I sine of theta subscript 0. So let this be a complex number. Where, okay, n I'm about to define n because I'm going to need to use it after. Again, it's any integer. Okay, so that E symbol means it belongs in this set of integer. And this integer, I want to start to be at 2. Okay, so greater than or equal to 2. Okay, so earlier we said n was, we can use n can be 1. Okay, now we're going to say n can be 2. So n can be 2 or bigger. So if W is never to be 0, okay, there are distinct complex nth root of W given by the formula. Okay, here's the formula. Z, remember Z is just the complex root of subscript K. And don't be scared of K. Okay, it looks scary, but it's really not. Once we use it, you're going to be like, oh, it's not so bad. Of nth root of radius, whatever the radius is going to be. Okay, times cosine of theta, my first angle here. So theta subscript 0 is just really the first angle. Divided by n. Remember, n is the root, okay? Nth root. Plus 2 pi k. It's just a revolution there. And then divided by the nth root. If we are in degrees, 2 pi k becomes 360 degrees k. Plus I times sine of the same thing. So theta subscript 0, that means the first angle, divided by the nth root, plus 2 pi k divided by n, and close that up. Where k, okay, is, we're going to start at 0, we're going to go to 1, we're going to go to 2, dot, 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 okay, and then n minus 1. So if your root is 4th, then the maximum k you're going to go to is 3, okay, because 0 is your first root. Okay, that's why it's starting at 0. So when we use it, I want you, so if I'm asking for you to find the 5th root, okay, then that means you're going to go to z of 4. If I'm asking you to find the 4th root, then you're going to go up to z of 3. So k is starting at 0. So that's why the max is going to be 1 less than the number itself. Okay. So now that we have new extra formulas, let's go and use it, okay? So with this one, it said write each expression in the standard form of a plus bi. Well, look at this one. This is really, you can go about this in multiple ways, right? Notice how the power, this doesn't have any power, so it doesn't seem like it has any power. The power is actually 1, okay? So we can put a 1 power there if you want, or if not, no big deal. You can work this out normally, or you can use De Moivre's theorem, okay? Because De Moivre's theorem does say that the power can be 1. So it says, hey, when you raise to the power, then it just simply take your radius, raise it to the power of 1, okay? Then cosine, okay? If the power 1, you just times your normal angle. Oh, did I just delete that? Okay, so that's what we're going to do, okay? Now, but 1 to the any, like, raised to the power 1 doesn't really have anything, right? So here we go. Radical 3 to the power of 1. It's still the power of 1, no big deal. Cosine of 5 pi over 18. This is not the one that you could do by hand or, you know, by memory. So I'm going to punch it in. Ready? Cosine, let me see if I'm in radians. I am in radians. Perfect. Cosine of 5 pi divided by 18. This is giving me a 0.643 plus I. Okay, let me do this square bracket. I times sine of the same thing. So that's going to give me 0.766. So now I will try to distribute your rad 3. So here we go. So this is times radical 3. since I already have this on my calculator, I will just write this first, 1.327i. So that's that one. I'm going to take my calculator to multiply. So let's see, rad 3 times cosine. Radical 3 times cosine of 5 pi divided by 18. And that gives me 1.113. 1.113. Okay, so that is the form of a plus bi, or you're used to seeing this, x plus yi. Either one, it's exactly the same. So we'll highlight this, and that's your final answer. You can box it up if you don't have a highlight handy. Okay, next. We have now raised to the power. So really, this is a true test of how do we use De Moivre's theorem. First, we have to put it in polar form, okay? So let's plot out 1 minus rad 5. So that's going to be in quadrant number 4. Let's find the radius. Radius is square root of x squared plus y squared. X is going to be 1. 1 squared is 1. Y is negative rad 5. Negative rad 5 squared is 5. So this is square root of 6. Let's find theta. Theta is tangent inverse of y divided by x, which is y is going to be negative rad 5 divided by x is 1. I don't have this memorized, so I would definitely have to use a calculator. So let's punch in my trusty calculator. Because this one is originally in rectangular form and you are now converting polar, so try to use degrees, okay? If it starts out in radians, keep it in radians, but because it's not, we're going to use degrees. So tangent inverse of negative radical 5 gives me a negative 65.9 degrees, okay? But you cannot have a negative angle, so keep that in mind, okay? So negative 65.9, okay? Degrees. So what do we do with this? Okay, we are going to find an answer. Can you tell me what to do next? How do I get a positive angle for that? Can you tell me what to do from here? I can't use negative angles, so what would you do to get positive angle? Should you add a what? A 360? Sounds like a great idea. Okay, so add 360. So did we end up with 294.1? Okay, so 294.1. So negative 65.9 is the same location in the positive direction. Okay, so we're going to try to use a positive angle. So here we go. So you have this now in the positive angle. Radius is positive. Let's rewrite it. So instead of writing 1 minus rad 5i to the 8th, we're going to keep it in polar. Okay. So rad 6 is our radius. Cosine of 294.1 degrees plus I times sine of 294.1 degrees. So all of this is raised to the power of 8th. We haven't done that yet. So based on De Moivre's theorem, we're going to take the radius and we're going to raise it power of 8th. Okay. Then we are going to multiply 8 to each angle. So 8 times 294.1 degrees plus I times sine of 8 times 294.1 degrees. And I'm going to use my calculator. 294.1 degrees times 8 equals. All right, so this is going to give me some ginormous number. Here we go. Cosine of 2352.8 degrees. Okay, so I'll bring down the radius in just a second. Since I have this on my calculator, I don't want it to go to sleep, so I'm going to copy that down. So rad 6 to the 8th is actually the radicals are gone. So now that's just going to be 1296. So that's your radius. No, we're not going to keep it in polar. Okay, so we're going to convert it back to a plus bi. Okay, so a plus bi, it has to be, so what is cosine of that huge number? So this is maintained as 1296, okay? Cosine of this huge number is negative 90.975 plus, what is sine of that number? Sine of 2352.8. 2352.8, okay? And do double check my math. I want to make sure I'm going the right page here. So negative 0.222 if I'm rounding it to 2 decimal places, okay? Okay, so here we are. This is what we have. So now I have to distribute, okay, like that. So, oh, I forgot that I. There you go. So let's distribute 0.222 times times 1296. So 0.222 times 1296. This is giving me a negative 287 point. I'm just gonna round it to 2 decimal places, so that 0.71i. In the front, negative 0.975 times 1296 is negative 1263 point. Well, this one just gave me 1 decimal place, so perfect. So this is now my final answer in the format of A plus BI. And this is the end of our recording for today.